So in this question, it's the first time that we will encounter two-dimensional collisions. So what we have right now is we have a billiard ball, A, that collides with another billiard ball at rest, but it's not head-on collision. So after the collision, they move in different directions at an angle. So let's say A moves this way, B moves that way. So we will call the mass of A ma, the mass of B mb. And the initial velocity, VA, after the collision, it's VA prime, VB prime, and the angle, we'll call it VA, theta A prime, and theta B prime. So for part A, it asks us to write the conservation of momentum in two different directions, assuming that the initial direction of A is x-axis. So let's call this x and call this y. And conservation of momentum works the same way, except that now we have to deal with two directions separately. So for x-axis, the initial momentum is MAVA. And after the collision, the momentum becomes MA VA prime, but if we decompose it, the x component is cosine theta A prime. And same for B, it becomes MB VB prime cosine theta B prime. That is for the x-axis. What about the y-axis? Before, there's nothing moving in the y-axis because A is along x and B is at rest. So we have 0 before the collision. After the collision, if this is positive direction, then we have A moving in the positive direction and B moving in the opposite direction. So we have MA VA prime. This component is sine theta A prime minus MB VB prime sine theta B prime. Great. So these two are the conservation laws of momentum in the x-axis and y-axis. For part B, it asks us to actually solve for theta B prime and VB. And it asks us to not assume that it's an elastic collision. So we cannot use anything about kinetic energy. All we have are these two conservation of momentum equations. Let's see whether we got all we need. We have two equations, and we already know MA, VA prime, and theta A prime. So the only two unknowns are VB prime and theta B prime. So we have two equations and two unknowns. So that's enough for us to find what we want. Let's first try to find theta, since we have both cosine and sine, and it will be painful to deal with it if we, so it will be pain to like deal with the theta b if we want to find VB first, because we cannot simply convert cosine to sine. So let's first find theta b. The best way to find it is to first express both sine theta b prime and cosine theta b prime in terms of other quantities. So let's find this. From sine theta b prime can be found in this equation. And we got that it's equal to MA VA prime sine theta A prime 3n over MB VB prime. And cosine V prime can be found from this equation. And it is MA VA minus VA prime cosine theta A prime over MB VB prime. And we can see they both have MB VB prime in their denominator. So if we just divide them to get tangent theta B prime, we will be able to cancel the VB prime. So we do not want its denominator. So we get this equals VA prime sine theta A prime VA minus VA prime cosine theta A prime. Great, because all of the quantities in this expression is already known. So we can, from that, we will be able to find theta B prime equals arced tangent VA prime sine theta A prime VA minus VA prime cosine theta A prime. And we simply plug in everything we already know. So this is 2.1 meters per second times sine 30 degree over 2.8 meters per second minus 2.1 meters per second times cosine 30 degree. If you enter everything into the calculator and try to find the arc tangent of this number, you will get 46.9 degree. So that is this degree we are looking for. And with that, now we will be able to find VB prime. And we can do that from either of these equations. I'll just use this equation. And I'll write it so that I have VB prime on the left-hand side. So VB prime equals MA VA prime sine theta A prime over MB sine theta B prime. Great, and which again, just plugging everything, we have MA equals 0.12 kilogram times 2.1 meters per second times sine 30 degree, and we have mass of B is 0.14 kilogram times, now we know what sine is 46.9 degree, and that gives us 1.23 meters per second, and that's VB prime. So that is the velocity and angle of this billiard ball after the collision. It's moving in an angle that is 46.9 degree with respect to the x-axis, but it's towards the negative y direction. And it has a velocity of 1.23 meters per second.